Hello students, today we are going to complete the next part of the first lesson electrostatics. This is the episode 7. Now let's see an expression for electrostatic potential due to a point charge. Look at the picture. You can see a charge q which is in the position origin. Then we find a point charge which is at P. The distance between the point charge and the charge at the origin is R. The equation for bringing this positive test charge Q, that is Q dash, from the point R, that is from this unknown distance infinity, against the repulsive force. We are doing a work to take the charge from the point R, which is unknown, to this position P, and the work must be done to overcome this repulsion, because this Q and this Q dash will have some repulsive force. It is not easy to bring the point charge from the infinity position to this point, so it will have a repulsive position. So we do the work against this repulsive force. The work done is stored as a potential energy here. This work done to bring this charge from here to this point is stored as a potential energy. So we see the potential energy, that means the energy velocity V is equal to integral infinity to R. That means this from infinity to R, which is minus E into dr vector. There R represents the distance between Q and P. So while integrating this, we can take the minus symbol out, because we put this minus symbol because it's from the unknown distance. Okay, so we put minus here and integral infinity to R E dot dr. Then the electric field, that means this electric field due to a positive point charge Q. Here we also have a positive point charge Q as from the Coulomb's law. E is equal to 1 by 4 epsilon 0 Q by R square into R cap. While we substituting this E value in this equation, we will get V is equal to minus 1 by 4 pi epsilon 0 integral from infinity to R Q by R square into R cap into this dr. We have to put this dr here. Then the infinitesimal displacement vector, that means this infinitesimal displacement vector dr vector is equal to dr into r vector, and while using this r into r we get 1, so we can neglect this infinity value. So we substitute this value as 1 by V is equal to minus 1 by 4 pi epsilon 0 integral infinity to R Q by R square into R cap into drr. So we substitute this R into R cap as only dr. After integration, we have integrated the R and infinitive and R. V is equal to minus 1 by 4 pi epsilon 0 Q. We can take Q out. Only we can integrate the 1 by R, and if you integrate this, you will get 0 for infinitive and only R for the value. So we can put 1 by R for instead of this value. And again we have 1 minus here and another minus, so we can put plus here. We put plus here because of this minus and this minus. We substitute all this and now we put plus. Then hence the electric potential due to a point charge Q at a distance R, which is equal to V is equal to 1 by 4 pi epsilon 0 Q by R. Hence, if a source charge Q is positive, then V is equal to 0. If Q is negative, then V is negative, and which is equal to V is equal to 1 by 4 pi epsilon 0 Q by R. Now the electric potential at a point due to collection of charges, that means the charges are not only one, that means the Q1 or Q2, it are collection of charges, that means from Q1 to Qn, which is equal to the sum of electric potential due to the individual charges. So we get V total is equal to, this is collection of all individual charges. K is a value, we substitute for this 1 by 4 pi epsilon 0. Then K into Q1 by R1 plus K into Q2 by R2 plus K into Q3 by R2 till KQN divided by Rn. If we use all this, it's a tedious equation, so we use the summation. That means 1 by 4 pi epsilon 0. That instead of K, we put 1 by 4 pi epsilon 0, and if sigma n is equal to I to 1 is equal to 1. Therefore, Qi by Ri, where here R1, R2 and R3 till Rn are the distances, and Q1, Q2, Q3 till Qn are respectively from the point P. Now we are going to see the expression for electrostatic potential due to a electric dipole. Let me show the electric dipole. Consider two equal and opposite charges separated by a small distance 2a. This is a one charge plus minus q and another charge which is plus q. Now the distance between the A and O is small a, and O and B is small a. At the same time, the distance from O to P is R, and A to P is R2, and B to P is R1. The point P is located at a distance R from the midpoint of the dipole. Now let theta be the angle between OP. Theta is the angle between OP and dipole axis AB. Let R1 be the distance between the point P from Q, and R2 be the distance between the point P from minus Q. Here the angle between AOP is 180 degree minus theta. How we consider 180 degree minus theta? See, if you take this as 0 degree and this as 180 degree, this is 180 degree, this angle is 180 degree minus theta. Then the potential at P due to the charge plus Q at V1, okay, charge plus Q at V1, that is 1 by 4 pi epsilon 0 Q by R1. The potential at P due to charge minus Q, V2 is equal to minus 1 by 4 pi epsilon 0 Q by R2. We put minus here because it is 180 degree minus theta. So we substitute minus here instead of plus. If you combine the values of V1 and V2 as V, then we get 1 by 4 pi epsilon 0 Q 1 by as a common, there is a 1 by 4 pi epsilon 0 Q as a common, and 1 by R1 minus 1 by R2. Now we have to find the values for 1 by R1 and 1 by R2, and we have to substitute the values of 1 by R1 and 1 by R2 in the equation 1. Then only you can find the final expression for the electrostatic potential due to an electric dipole. Is it easy for you, students? Okay, now suppose if the point P is far away from the dipole such that when R is very much greater than A, then the equation 1 can be expressed in terms of R. And using a cosine law for the triangle BOP, we get R1 square is equal to r square plus a square minus 2ra cos theta. r1 square is equal to r. If you take this r square as a common in this equation, then we can put r square, instead of that r square we put 1 minus 2a cos theta divided by r, because this second term don't have a r square value, so we divide this by r square, and we can cancel this r for that r square, and so we have to subtract that by r. Then if you take the square, this square value out, if you take the square value out for the left hand side, then you have to take the same to the right hand side also. If you do that, then r instead of r1 square we put r square, r1 then which is equal to r, because we take this square here. Instead of making here a square root, we put 1 by 2. You understand? Instead of making a square root, we put 1 by 2 here. Then actually we need the value of 1 by r1, not r1 value. For the equation 1, we need the value of 1 by r1. So if you substitute the if you divide by 1, then we get 1 by r1, and you have to divide the right hand side also. So 1 by r is into 1 minus 2a r cos theta, the whole bracket. Already we have 1 by 2. Now we put minus 1 by 2, because if you take the value from the ground to the upper level, you have to put minus. I think you all know that. Since a by r is very much less than 1, we can neglect the value a by r. We can use a binomial theorem and retain the terms up to first order. That means 1 by r is equal to 1 by r into 1 plus a by r cos theta. That means we can have this minus here, so this makes here plus, and if you cancel this 2 and this 2, okay, then we will have a by r cos theta. Do you understand? Similarly, applying the cosine law for triangle AOP, as we done in the ABOP, r2 square is equal to r square plus a square minus 2ra cos theta, which is 180 minus theta. If you get the value 180 minus theta for cos, then we will have minus here. And if you substitute this minus in this equation, then this term will be plus. So r square is equal to r square, r2 square is equal to r square plus 2, that means a square plus 2ra cos theta. Neglecting the term a square by r square, we can neglect the term a square by r square, because r is very much greater than a, and we can put r2 square is equal to r square 1 plus 2a cos theta by r, as in the equation number 2. Then if you take the square root here, you have to take the square root from the right hand side also. So r2 is equal to r into 1 plus 2a cos theta divided by r, the whole bracket 1 by 2. Now using binomial theorem, we get 1 by r2 is equal to 1 by r into 1 minus a cos theta divided by r. As in the last equation 2, we substitute the value plus minus here, and we cancel the values 2. Okay. Now substituting the equation 3 and 2 in equation 1, that means v is equal to 1 by 4 pi epsilon 0 q into 1 by r1 minus 1 by r2. We substitute that values of equation 2 and equation 3 here, then we get 1 by r, 1 plus a cos theta by r minus 1 by r, 1 minus A cos theta by R. Taking the 1 by R common and Q by 4 pi epsilon 0 common. Okay, Q by 4 pi epsilon 0 common. We have 1 plus A cos theta by R minus 1 plus A cos theta by R. So we can take 1 by 4 pi epsilon 0 into 2AQ R square cos theta. If you substitute the value P is equal to 2QA, then we get V is equal to 1 by 4 pi epsilon 0 P cos theta divided by R square. Finally, now we can write P cos theta is equal to P vector into R cap, where R vector is the unit vector from the point O to P. The final expression will be V is equal to 1 by 4 pi epsilon 0 P into P vector into R vector R cap divided by R square. There are three special cases for this equation. First one, if the point P lies on the axial line of the dipole on the side plus Q, then theta is equal to 0. We know cos 0 degree is equal to 1. So then the electric potential becomes V is equal to 1 by 4 pi epsilon 0 P by R square. In the case 2, if the point lies on the axial line of the dipole on the side minus Q, then theta is equal to 180 degree. As you know, if it is 180 degree, it is minus 1. So if we have to put minus here. V is equal to 1 by 4 pi epsilon 0 P by R square. In the last case, if the point lies on the equator line of the dipole, then theta is equal to 90 degree. As you know, 90 degree is equal to 0. If you multiply the value of V by 0, that means if you substitute the cos theta is equal to 90 degree, then it will be 0. So V is equal to 0. Thank you, students. I think you all learn with me with this all the questions. So all are very important questions. If you feel any problem, if you feel anything hard to learn by the today's lessons, kindly call me. Thank you.